In this video, let us review simplifying radical expressions. So the word radical simply referring to square root, cube root, fourth root, and so forth. So right now I got two examples here to simplifying your square root expressions. So whenever we have a number inside the radical that is not perfect square or perfect cube, we got to be able to simplify them. So there are there are two key ways to go about doing it. One way is to use prime factorization to break down um, what you got inside the radical and make sure it's one term inside the square root or cube root in order to break them down. So if I just simply want to break down the 18 using prime factorization, 2 can go into 18 9 times. 2 go into 9 3 times, and 3 go into 3 1 times. So what I'm looking for is two of the same numbers to go outside as one of them. The reason why I only need two of the same number is because I'm working with the square root. So these two will go outside as 1 2. The 3 cannot go outside, so that stay inside the square root. So that becomes 2 times square root of 3. So if I have an example that is cube root of 18, then this time I would need 3 of the same numbers to go outside. So once I break down the 18, I see that, oh, sorry. Oh, I made a big boo-boo right here. Let me start this over. Hold on. All right, 18 is 2 go into 18 9 times, 3 go into 3 3 times, 3 go into 3 1 time. So these two threes will go outside as one of them. Is the 2 that will stay inside. Sorry about that. Now, back to the cube root of 18, looking for 3 of the same numbers to go outside as one of them. So since I don't have 3 of the same factors of 18, then this 18 don't need to be breaking down, okay? Because nobody can go outside. So we would just keep it as cube root of 18. All right. So what do I mean earlier by it got to be one term inside the radical? So what's inside the radical is called radicand. If what's inside the radicand is two terms, then there's no point for you to break them down, okay? Because you got to make sure, okay? You got to make sure it's only one term inside the radical in order to break it down. So if I have something like a square root of 4x squared, then I can break this down because this is actually only one term. So square root of 4 is 2, right? Coming out of the radical is 2. All right, square and square root can cancel out. Or if you do Math 108, we say take the exponent in the inside divided by the roots. That will tell you how many goes out, how many stays in. So 1x comes out. So square root of 4x is simply 2x. All right. Now, you probably encountered the imaginary numbers before. So square root of a negative is always equal to imaginary number I. All right. So I know for this example, my answer will have an I in it. So all I got to do is break down my 24 using my prime factorization. So I can use 2. Okay, 2 go into 24 12 times, 2 go into 12 6 times, and 6 is only 1 2 and 1 3. So these two 2's will go outside as 1 2. The 2 and the 3 cannot go outside, so they got to stay inside, which will be 2 times 3, which is this 6 right here. So you can say 6 remain inside. Square root of negative 1 is an I. All right. So different way to go about it. Some students say, well, Mr. Chan, what can't you just say 4 go into 24 6 times? Square root of 4 is 2. Yes, you can say it like that as well. But then if I have a cube root of 24, okay, then you will have to say the 24 is 8 times 3. Or you can break it down like using the prime factorization and picking 3 of the same number to go outside as 1. The 3 stays in the inside the cube root. Okay, either technique will work. The bottom line is when it's time to simplifying radicals, I just need to make sure you know how to break it down. Okay, this is only a one little piece of a problem that we are going to that we may encounter. All right, that will conclude this video. Thank you for watching.